Hip, hip, hooray, there's just 3 things to do. StatQuest. Hello, I'm Josh Starmer and welcome to StatQuest. Today we're going to talk about 3 things to do when starting out in data science. Thing number 1. Be curious about the data. In data science, or bioinformatics, or statistics, or machine learning, or whatever, we work with a lot of data. For example, we might have clinical trial data, or we might get data from a research lab, or we might get data about how people interact with a website, or from sensors at a weather station, or from community surveys or political polls, or any other source. The possibilities are endless. Given that, regardless of the source, data usually consists of numbers and words in a spreadsheet, it is tempting to think that is all there is to data, just a bunch of stuff in a spreadsheet. But data doesn't just magically appear in a spreadsheet. It has to be collected, usually by people, from a source, which is usually other people. And anything that involves people tends to be more interesting than the numbers in a spreadsheet might suggest. For example, maybe we are studying lung cancer, and this person has lung cancer, and we isolate a bunch of cells from the tumor, and then we get measurements from each cell. What can we learn from this data? Well, that depends. First, we need to know about this person. Do they smoke? Are they old or young? Do they have a race or ethnic identity? The answers to these questions give us context for the data and limit what we can extrapolate from it. If this person smokes, then we may need to restrict our conclusions to smokers. If this person is young, we may need to restrict our conclusions to young people. And we may need to restrict our conclusions to a specific race or ethnic identity. And there are a ton of other factors that narrow the scope of our conclusions. People often talk about bias in analytics, and this is where a lot of that bias can occur. For example, if we only collected lung cancer samples from white males, then our results may not apply to the majority of the population. So it's super important to know about the source of the data. Now, what do we know about the person who extracted the cells? Were they an expert who had extracted lung cancer cells 1,000,000 times? Or was this their first time? The answers to these questions suggest how pure or contaminated the sample is. If we believe the sample is contaminated, we may have less confidence in the results. So it's important to know how the samples were handled. Lastly, who prepared this table? Were they an expert, or was this their first time? If it was their first time, did they do it right? If not, the data we input to our analysis algorithms may not be what we think it is. So it's super important to know how the data were processed. So we see that at every step of the way, there is a person that influences the data, and, ultimately, how the data should be interpreted. So, my advice is to go to the clinic and meet the patients. You may notice something that no one else noticed, and that thing could be critical to the analysis. Then, meet the people collecting the cells. If you're lucky, they may let you observe the process. Again, this gives you a chance to notice things that other people who are not focused on the analysis might miss. Lastly, meet the people that create the dataset to learn about what they do. This gives you a chance to validate the assumptions you have about the data. In the end, we see that data isn't just data. It's not just numbers and words in a spreadsheet. Instead, it is a process, and each step in the process influences how the numbers and words in the spreadsheet should be interpreted. So, maybe instead of calling it data science, we should call it people science, because it's as much about understanding people and what they do as it is about the data. In summary, be curious about the data. Bam! Thing number 2. Be curious about the methods. Data science, or bioinformatics, or whatever, is chock full of methods. Statistics, machine learning, database. This is a blessing because we have a lot of tools to use. But it is also a curse because it takes time to keep up with them all. However, it's important to keep up with the methods in order to understand their limitations. Here's an example. When I made the StatQuest on neural networks, I started with a really simple dataset that showed whether or not different drug dosages were effective against a virus. The high and low dosages were not effective, but the medium dosage was effective. Then I fit a neural network to this data and got this green squiggle. And the green squiggle fits the data pretty well. When the dosage is low, the green squiggle is close to zero, and the neural network predicts that the drug is not effective. And that is consistent with the data we use to train the neural network. When the dosage is 0.5, the green squiggle is close to 1, and the neural network predicts that the drug will be effective. And this prediction is also consistent with the data we use to train the neural network. Lastly, when the dosage is high, the green squiggle is close to 0, and the neural network predicts that the drug will not be effective. And that, too, is consistent with the data we use to train the neural network. So we see that the green squiggle fits the 3 points in the training dataset pretty well. But let's be honest, this bump looks a little weird. If you asked me to fit a squiggle to the data, I might fit a nice arc like this. This arc makes sense to me because the output values are all between 0 and 1, just like the original data. And as the dosage increases from 0 to 0.5, our confidence that the dosage will work also increases in a nice, consistent way. Likewise, as the dosage increases from 0.5 to 1, our confidence that the dosage will work decreases in a consistent way. But the neural network did not fit an arc to the data. Instead, the neural network fit a green squiggle that has this weird bump that goes over 1. And the training data never went over 1. So where does this weird bump come from? Well, if we knew how neural networks worked, we would know that the green squiggle is only penalized where there is data. In other words, the neural network will be penalized if the green squiggle is far from these 3 points. And, as a result, the green squiggle is close to all 3 points. However, the green squiggle is not penalized where there is no data. And, as a result, the green squiggle can do whatever it wants between the points. So, because of how neural networks are randomly initialized, I ended up with this bump. But I could have just as easily ended up with a neural network that had a bigger bump, or 2 bumps, or whatever. The point I'm trying to make is that just because it makes more sense to us to fit a nice arc to the data like this, it doesn't mean the neural network won't fit something crazy like this instead. And that means it can be hard to trust the output from a neural network that is making predictions between data points. I think about these in-between data predictions whenever someone talks about using a neural network to drive a car. People are very good at extrapolating between experiences in ways that other people can relate to. In contrast, neural networks do whatever they want between experiences, and other drivers may not relate to that. And that's just one example of why knowing how the method works can be important. So be curious about how the methods work. Double bam! Thing number 3. Just be curious. What we do in data science, or bioinformatics, or whatever, is usually a small, but super important, piece of a much larger puzzle. We aren't just plugging in data and hitting return, but we are also helping to cure diseases, or helping lift people out of poverty, or bringing smiles to people's faces, or helping people in new and exciting ways. And I believe it is important to see the big picture. Our work does not exist in a cave, but is always in the service of people. And we should always be aware of how our work is used. Is our work being used to make the world a better place? Or not? The only way to find out is to be curious about the other pieces, and to figure out what they do, and see the big picture. And I can't show you that big picture. You have to find it yourself. So be curious. Triple bam! Hooray! We've made it to the end of another exciting StatQuest. If you like this StatQuest and want to see more, please subscribe. And if you want to support StatQuest, consider contributing to my Patreon campaign, becoming a channel member, buying one or two of my original songs, or a t-shirt or a hoodie, or just donate. The links are in the description below. Alright, until next time, Quest on!